Section 2.1, we're going to write, interpret, and simplify expressions. So our objective is to write an algebraic expression, interpret the parts of it, and use the distributive property to simplify it. So first, vocab. We need to know what an expression is. An expression is a math phrase. It is made up of numbers, variables, and math operations. Okay. So, for example, a expression 16 plus 5 is an expression. This one's just made up of numbers, but it's just a phrase. 5a plus 6 is also a phrase. One thing to note, expressions do not have equal signs. If it's an equal sign, it's an equation, not an expression. Expressions do not have equal signs. Okay? So it's just a phrase. Now we can simplify those phrases. So like, for example, the phrase 16 plus 5, I could simplify that to 21. Okay, these are what we call equivalent expressions. They have the same value, but they're written in different ways. So often you'll be asked to evaluate an expression or simplify an expression. And really what that means is to get it written in the smallest way possible. 16 plus 5 can be written smaller. It can be written as 21, okay? All right, so the different parts of an expression, we call its terms. The terms are the parts that are added together. In an expression. Okay, so for example, this one that I did up here, this 5a plus 6, has two terms, a 5a and a 6. Those two pieces are added together. Okay, it's got two terms. Sometimes you might have to rewrite an expression to show that it's addition. What I mean by that, if I had 6x minus 4 plus 8y, well, I have a subtraction in here. So the first thing I'm going to do is I'm going to rewrite that subtract as adding a negative. So there I can see the three terms, a 6x, a negative 4, and an 8y. It has three terms. A 6x, a negative 4, and a 8y. Okay. Now, a coefficient. A coefficient is the numerical part or the number part of a variable term. A coefficient is just a number. Okay, so in this previous problem up here, this 6x minus 4y equals negative 8, the number part in the variable term. So this first term is a variable term. It's got an x in it. So the coefficient is just the 6. This 8y is a variable term, so the coefficient is just an 8. Okay, and we've had the discussion before. If I just have a variable with no number part, for example, let's take x plus 5. That has a coefficient of 1 because it's only one x. So the coefficient is 1 if there isn't a number written in front of it. 1 just tends to be that number we don't write. Okay, it's only one x as opposed to this one having 6 x's. Okay. Now your turn. I want you to go ahead, pause the video, and I want you to answer these three questions. How many terms does that have? What are the coefficients? And is 5 a coefficient? Okay. All right, now that you've done that your turn problem, I want to talk about that number 5. Okay, that number 5 is not a variable term. Okay, so do we call it a coefficient? No. Coefficients. So this last one, is 5 a coefficient? No. It's actually what we called, it is called a constant. Because it does not change. That 5 is always 5, regardless of what the variable is. As the variable changes here, as x changes, this 2x term is going to change. As y changes, this negative 8y to the second term is going to change. But this 5 doesn't care what x is, doesn't care what y is, it's always 5. Hence why we call it a constant. So that's some important vocabulary there. It's called a constant. Okay. All right, now a review of the distributive property. The distributive property is a way to, say, shortcut a multiplication and addition. So basically what this distributive property tells me in symbols, if I have A times B plus C, okay, so here I have A. Order of operations would tell me I would need to add B plus C first, in parentheses, and then multiply by A. But sometimes that's not possible, especially when if B and C are variables. So what the distributive property tells me is that I can multiply the A times the B, multiply the A times the C, and then add them. And it's add because this middle term is add. Okay. So that is the distributive property. How that would look in numbers, if I'm taking 3 times 4 plus 2. I could follow order of operations and add 4 plus 2. And we're going to do it both ways. Or I could take 3 times the 4, take 3 times the 2, and add it. 3 times 4 is 12, plus 3 times 2 is 6, and I get 18. That would give me the exact same thing if I take 3 times 4 plus 2 is 6. 3 times 6 is also 18. They are equivalent expressions, okay, using the distributive property. Okay. Like terms, when it comes to simplifying these expressions, we have to be able to identify which terms are like or alike. Like terms are any terms whose variable and their exponents are the same. Variable and exponent parts are the same. Okay, so the term x and 6x are alike. And notice I don't use an equal sign. They're not equal. They're just alike. Whereas x to the second, let's go 3x to the second, and negative 5x to the second are also alike because they're x to the seconds. But like an x term, 6y to the third, okay, and negative 1/2 y to the third, put a comma in between, are alike because they're both y to the third. The entire variable part has to be the same. X squared y, x to the second y, and 2/3 x to the second y are alike. But notice x is to the second in both of them, and they both have a y. Okay, they're like terms. Okay, again, the x has to be to the second, and they each have to have a y. Not like terms in this, if I had x, y to the second, that's not alike. I'll just put a 3 in front. This one is not alike to that one because the variable part's different. The exponent part's different. Okay, so we're going to be spending a lot of this next section looking at like terms because you can only add like terms. Okay, because we're going to be writing what's called equivalent expressions. Equivalent expressions are expressions that have the same value. I talked about that earlier when I wrote 16 plus 5. 16 plus 5 and 21 are equivalent expressions. Okay. Okay, I want you to go ahead and pause the video and do this next your turn problem. Which of those following are like terms? All right, now that you've done that your turn problem, let's go ahead and let's do some examples. We're going to simplify each expression. Here's the expressions we're simplifying. So this is going to involve us identifying like terms, distributive properties, so forth and so on. Okay, so the first thing I notice, order of operations tells me I really should do inside parentheses first. But these two terms are not alike. 5x plus 1, they're not alike. I can't add them. So I can't do inside parentheses first. So I have my parentheses multiplied by 4. Here I have my multiply by 4. That's a multiply. I put my dot in there. So here I'm going to use the distributive property. I'm going to take 4 times each of those pieces. So I'm going to take 4 times 5x, which is 20x, and then 4 times 1 plus 4. And then I'm going to rewrite this next bit, this subtract 3 as plus a negative 3x. So now it's straight across addition. So since it's straight across addition, I can add it in any order. So I'm going to add my like terms. These two are like, they both have x's. So I can add them. They're both x's, they're alike, I can add. So 20x plus negative 3x, so 20, basically I always think, okay, 20 cats, negative 3 cats, I'm going to have a total of how many cats? They're still cats, they're still going to be x's. So same signs add and keep, different signs subtract, so that's going to give me 17 x's. And then I haven't done anything with that plus 4, so he comes along. Notice how I'm not using any equal signs. I'm just working down my page, one line, then the next. Okay, and then I look, do I have any more like terms in here? This is an X term, this is not. Nope, they're not alike. So there's as far as I can go with it. Each of these are equivalent expressions. This is equivalent to this, and this is equivalent to this. Okay, we're just rewriting it. Okay, holy negative sign for this next one. There are so many negatives in here. I'm going to start by rewriting this and changing all of my subtracts to plus and negative. Trust me, it makes life easier. So this first one isn't a subtract, that's a negative 7. This next one, x minus 5, I'm going to write it as x plus a negative 5. Now this next one is subtract 3 plus a negative 3. Then 4 plus a negative 5x. I can almost guarantee if you don't do this step, you're going to get your signs wrong. Your negatives are going to get all mixed up. Okay. Order of operations, work inside parentheses first. Can I? Nope, not like terms. X and a negative 5, can't add them. So distribute it. Distribute. So I'm going to take negative 7 times x is negative 7x plus negative 7 times negative 5 is a positive 35. Okay. Next bit, I cannot do this addition until I deal with the parentheses or multiplication. Order of operations. I cannot add until I parentheses and multiply. So I can't parentheses because they're not like terms, but I can multiply. So I'm going to go ahead and I have to distribute here as well. So plus, from this plus, and we have negative 3 times 4, negative 12, plus, that's really from this one, negative 3 times negative 5x is negative 3 times negative 5 is positive 15x. Now, identify our like terms. Here I have an x term. Everything is adding. Add, add, add. So I can add in any order. So let's go ahead and let's add it to my 15. So negative 7 plus 15, same signs, add and keep. Different signs subtract. So that gives me 8x. Now I have my constants, my 35 and my negative 12, which is going to give me a plus, what's 35 plus negative 12? That's going to give me a what, 23? Okay. They are no longer like terms. 8x, 23, can't add them. Okay. Next, this one doesn't have nearly as many negatives, but it still has a couple. So the first thing I'm going to do is I'm going to rewrite those subtracts as negatives like we did in that last step. So 2/3. Please use 2 lines of paper for your fractions. 3x plus 9. Now I'm going to rewrite the subtract as plus a negative. Plus a negative 4/7. 21x plus a negative 14. Trust me, you're going to save yourself a lot of heartache by doing that first. Now I need to distribute. Well, first look inside my parentheses here. I can't put these together. One's an x, one's a 9. If you can, by all means, put them together. So I need to take 2/3 times 3. Now I could spend a lot of time coming over here to the side and taking 2/3 times 3. It's actually not that bad. 2/3 times 3 over 1 gives me what? 6/3, which is 2. So it ends up being 2x because there's still an x there. But if that makes you nervous, we can always pull up our calculator. In parentheses, take 2 divided by 3. That's 2/3 times 3, and it still gives me 2. Okay, so your calculator is completely okay to deal with those fractions. I need to take 2/3 times 9. Calculator, parentheses, 2/3 times 9 is 6. So plus 6. Plus, now I need to distribute, because again, I can't add these in here. One's got an x on it. Negative 4/7 times 21. Okay, negative 4/7 times 21. And again, with the graphing calculator, I don't need to like clear out the previous stuff. I can just go ahead and leave it up there. Negative 12. So negative 12x. And then take negative 4/7 times negative 14. Negative 4/7 times negative 14 is 8. Plus 8. Now again, everything's addition. So I can go ahead and add my like terms. So 2x, negative 12. 2x plus negative 12 is negative 10. Plus 6 and the 8 gives me 14. Negative 10x plus 14.